next class is starting. Okay. So today we're going to work out several problems as your example for oscillation and wave part. Okay, first look at this problem. If you have a simple harmonic motion, which is described by the position function x equals to 3 times cosine 2 pi t plus half pi. Okay. We want to calculate several quantities. First, okay, so you have x equals to 3 multiplied by cosine 2 pi t plus pi over 2. Okay, so please note that for this problem, there is no difficult, complicated analysis. Okay, it's more about the conceptual calculation. Okay, what do you know? What quantity you are going to calculate? You need to know. So first, t equals to 1 second. What is displacement? So what is the displacement at t equals to 1 second? Okay, what's that? Can you give me the number? 0. T equals to 1 second. How do you get 0? Okay. What's the quantity you want to calculate for part A?
3 cosine 5 pi over 2.
So it's simply x equals to 3 times cosine 2 pi plus pi over 2. Okay? And what's that? 0. Okay. Oh, let's check. Okay. By the way, can you see this is 0? Because that's 3 times cosine half pi. Okay, cosine 2 pi plus half pi is cosine half pi, and cosine half pi is 0. Any question here? So at that particular time, the oscillation, the particle is at the center, the equilibrium position. Okay. B, velocity. So, if t equals to 1 second, what is the velocity? How can you calculate velocity here? First, you need to find the velocity function by taking derivative for this one. So if you take derivative, v should be 3 sine 2 pi t. Cosine, do you have a negative side? If you take, okay, so negative 3 sine 2 pi t plus 1/2 pi. And then you further to take the derivative for 2 pi t. So you will get a 2 pi in front of here. So 3 multiplied by 2 pi means 6 pi. Okay. So the velocity function is negative 6 pi sine 2 pi t plus half pi. Okay. Any question here? So you need first give the velocity function. And then it's straightforward. The velocity is you put t equals to 1 here, so you get negative 6 pi sine 2 pi plus pi over 2. Okay, so it's negative 6 pi sine half pi. Yes, okay, sine 2 pi plus some angle equals to sine of that angle. And what is sine half pi?
1.
It's 1, so negative 6 pi meters per second. That's the velocity, and time equals to 1 second. Any question here? And for this part, it's okay to keep just negative 6 pi like that. it's very common that for this part we use a lot pi instead of the actual number. Because many things is like multiple of pi, 2 pi, 3 pi, half pi. Any questions so far? Part A and B. C, okay. If t equals to 1 second, what is the acceleration? Okay, so you just need to further take the derivative, so you can get the acceleration function, which is, you have 1 more 2 pi, so it's negative 12 pi squared, right? Multiplied by cosine 2 pi t plus half pi. Okay. So acceleration is of course this cosine 2 pi plus pi over 2. So what's that? 0. Okay. Please note that the answer here, if you compare this one, when x equals to 0, acceleration is also 0. Mathematically, it's because both of them are described by the same kind of cosine function. So they are in phase. Physically, this means it's in the center, the equilibrium position of the oscillation. And at the center, if you think about the force, okay, there is no stretching or compressing, so of course, the force is 0. When the force is 0, the acceleration is 0. Okay. Okay, the phase of the motion, part D. We want to calculate the phase of the motion. So which quantity we are calculating? It's called phi. But actually, what quantity we are calculating here?
2 pi t plus pi over 2.
Okay, so we're calculating 2 pi t plus half pi. So it's 2 pi plus half pi, t equals to 1. So the phase is 5 pi over 2, right? Okay, so this is the phase of the oscillation at that particular time. Okay. In fact, it's also the argument used for the cosine sine function for this calculation. Okay? So you need to know what is phase. Now, for part E, okay. What is the frequency? Okay. Frequency is F. You want to calculate F. Okay. So, can you propose to calculate frequency? Which equation should we use to calculate frequency?
Position.
Position. What's that?
Position.
Position. You mean frequency can be calculated from this one? Let's see. I don't think so.
In
Okay.
frequency, when it starts at one position and goes back to the same position.
Yeah. Yes, that's a physical vision of the frequency, but it doesn't give you a simple way to calculate it, right? Okay. Frequency. Okay. You remember that we mentioned there is a very important quantity related to many other quantities. If you know that quantity, most of the quantity can be easily calculated. Which is that one important person? Who is that? Omega. Okay, don't forget that. So we need first calculate the omega and then calculate the frequency. What's the relationship between omega and frequency? Let's see. I think it's omega equals to 2 pi f. So f equals to omega over 2 pi. How do we know omega? Okay. Is there any way we can find omega here? 2 pi, right?
Yeah, 2 pi.
This is omega. Omega can be read directly from the equation. So pi over 2 pi equals to 1 hertz. The standard unit for the frequency is hertz. And 1 hertz actually means it will finish 1 cycle for each second. Okay. What's the next quantity we want to calculate? Period of the motion. Okay, you can calculate from omega, or if you already calculate frequency, so that's a period, right? 1 second. Any question here?
For E, how did you know omega was 2 pi?
For
E?
omega, you mean? This one? The equation of the position function in the original form is omega t plus phi. Okay? So if you compare your position function, you should know omega is 2 pi. Your initial phase, if you need, okay, we don't need it right here, it's half pi. Okay.
And the 3 would be the x sub m, correct?
The 3, okay, sorry. The general is amplitude. So if you want to know the amplitude for this oscillation, is 3. So that means the maximum oscillation position measured from the center is 3 meters. Okay. So the equation here, please note that when the equation in the physics, okay, they just give you some irrelevant number. Every quantity here has its meaning. Okay, this is the amplitude equals to 3. The angular frequency equals to 2 pi. Okay, the initial angle or initial phase is half pi. So it starts with some particular position. It tells you. Okay. Okay. Now, okay.